A U-tube shaped tube contains a liquid of density rho and it is rotated about a line as shown in figure. Find the difference in the level of a liquid column. So this H we have to find out. Now, before directly jumping to this question, we will see the concept behind this. The concept is okay. So liquid rotating with some angular velocity omega. Now consider a container in which some liquid is there. So this is the axis of rotation. Okay. So if liquid is rotating about this axis, the shape will become something like this. It will form a paraboloid shape. Okay. This is 3D. Okay. So that's why we will call it as paraboloid. Now, if I am considering one small dm mass here, okay, and on that small dm mass, one centrifugal force will be acting on that, that is mx omega square. Mass I have considered m. Okay, the m is here mass of this element. Okay, small element. Instead of dm, I am considering m here. Okay, and this small element is at a distance something x comma y. Okay, this is my origin. Okay, I have considered this is the origin, this is y-axis, this is x-axis here. Okay, so in this direction it is mx omega square. Downward there will be mg force. Now if I am resolving this mg, so I will get two component here. If I am resolving this mx omega square centrifugal force, I will again get two component here. If this angle is theta, okay, on this curve, this is like a tangent. Okay, so this angle, let's say this angle is theta. So this is at rest with respect to container. So I can say net force is 0. So mg sin theta will be equals to what? Mx omega square cos theta. So this I have written here, that is mg sin theta, which is equals to mx omega square cos theta. So after solving this, we were getting tan theta equals to x omega square by g, and tan theta is nothing but slope. Okay, the slope of this curve. This angle is theta, and we know that slope is what? It is dy by dx. So instead of tan theta, I have written dy by dx, which is equals to x omega square by g. So dy will be equals to dx idhar chala jayega. Now we have to integrate. Okay, now how we can put the limits here? Let's say at this point y is 0, x is 0, y is 0, x is 0. At some distance here, at some distance y, something x is here. Okay, so at some y, something x is here. So 0 to y, 0 to x are the limit. After solving this, we are getting x omega square by after solving this, we are getting omega square g is constant, so this will be the out of integration. So x ka integration aa jayega x square by 2. So we will get this result. Okay, now what will be the y here? Y is the maximum height attained by the liquid. So here maximum height attained by the liquid is h. Okay, this is the h here. Now omega is angular velocity, and r is this distance. Okay, radius of this container. So we are getting height, which is equals to r square omega square by 2g. Okay, now we will come to our question. We know that h is equals to r square omega square by 2g. Okay, this relation we have get. Okay, now in this question, the shape is again something like this. Okay, so this is the h here. So h, which is equals to r square means this distance. So here it is L. So it will be L square omega square by 2g. So correct answer is this L square omega square by 2g. So option A is correct here.